try, but today we'll be talking on design patterns with Python. Again, my name is Cleopatra Douglas. The major topics we're going to be looking at will be the objective-oriented designs, the design principle, programming challenges, business problems that can be solved with design patterns, and if time permits us, the several IDEs that we could use on that. No matter where we go today, the expectation is that at the end of this, you would have learned how to apply design patterns to create Python programs that are easy to write, read, and maintain. Because that's the use for design patterns, so that the next person will be able to read your code and work with it. We'll be looking at what are design patterns, why we need them, classification, principles of object-oriented designs. We'll be looking at the fundamentals of object-oriented design, solid, and definition of and defining interfaces in Python. So first things first, what are Python designs? A Python design or a design pattern is a model solution in a common design problem. It describes the problem and a general approach to solving it. In short, I tried as much as I can to put this in the simplest English. Christopher Alexandra, who is an architect, by the way, not a programmer, said, each pattern describes a problem which occurs over and over again in our environment and then describes the core of the solution to the problem. If we look at this, this is basically revolving around what we as programmers, what we do. We're just here to solve problems. And if peradventure you see a design in solving that problem and it's continuous, let's say somebody wants to learn how to spell his name, and you as a programmer, you found out that the process to spelling his name is one way. It's the same thing over and over again, no matter how you shift it. It's your duty to make sure that the next person who comes after you to show the next person how to spell that name sees that pattern that you followed and maybe decides to add something if there is an extension afterward, but still following a pattern so that it will keep going. Examples of everyday design patterns. Now, there are patterns in building architectures and automobile designs, electrical and plumbing codes, mobile phone interfaces, and so forth. Decoration, plenty things. There are patterns in our everyday life. Why do we need design patterns? We need design patterns to ensure that our work is consistent, reliable, and understandable. I've explained that the core reason why we need design pattern is so that whoever comes next can take over. I had a situation when I started working. I came in to the environment newly, and I could see all the codes, all the applications they had. Everything was it was right. And then, yes, of course, I noticed the pattern that the organization had been using to work. They had how you call your class, how you go about doing things in every code. I think there was even an SOP on that, on how you do things. But along the line, I think I had projects that were really pending. Everybody was, hurry up. And I drifted away from that pattern. I started doing things my own way because I could understand it. Yes, I was commenting, but I was not following the pattern. Now, when eventually I had a backup who was to assist me, the person took over one of the projects to expand on the project. And the person had already read the SOP or had seen the pattern that was used, only to get to the stage where I had worked on and I had not followed the pattern. So the person had to come back to me and was like, okay, so where did you do this? Which side did you do this? Meanwhile, in my own turn, I didn't do the same thing. I just saw it and I knew that, oh, this is where this person did this and this where this person did that. So design patterns really matters. Now, the classification for design patterns. We have creational design patterns, which is simple, to use for object creation. Structural design patterns for object relations or object relationships. We have behavioral design patterns for object interaction and responsibility. Now, for time being, we'll be concentrating on behavioral design patterns. That's what we'll be looking at for now. We're going to look at object-oriented programming, the fundamentals. There are 5 key things or 5 key rules which had been drilled into me, and I want to try and share it with you guys as well. They used SOLID as your acronym for that. S is single responsibility. This is trying to tell us that a class, for instance, should have a single responsibility. If this class, if say you want to write a cooking book, if this class is to hold the recipe, let the class hold the recipe. Let it not hold the kitchen utensils. O for open closed. A class, for instance, should be open for extension, usually by inheritance, but closed for modification. This is so that the next person, as the process for design pattern is, can see that, oh, this is this class for this. I can work on this to improve that class, but I cannot change that class. The next is the Liskov substitution. This is named after Barbara Liskov. Subclasses, for instance, should be added to stand in for their parent in a program without breaking. I'm sure this is understandable. The next is interface segregation. Many specific interfaces are better than one. Do-it-all interface. Python, I don't think that in Python, we use abstract base classes combined with multiple inheritance to achieve this interface kind of thing. The next is dependency inversion. Program towards abstractions and not implementations. Whatever instance I'm going to give here will be based on Python 2.7 above and 3.5. Now, the design patterns still work for all programming languages. I'm just saying that right now, whatever instance or slide I'm going to show with some codes, I have used either 2.7 or 3.5. The first pattern we're going to be looking at is the strategy pattern. And now, I said before that we'll be looking into mainly the behavioral classification. Now, strategy pattern is behavioral in classification. Now, this has to do with family of algorithms that encapsulate each one and makes them interchangeable. This pattern can also be known as policy pattern. We'll look at an example of an online shopping website or an online shopping, a shopping website, and we'll be taking a look at the shipping page. After you finish making your orders, and now you have to choose how you want it to be shipped to you. We'll be looking at FedEx, UPS, and Nigerian Postal Service as the 3 examples of the shipping services to use. But our client has told us that we should also make it extendable so that if tomorrow, let's say Max.ng decides that they want to come into the business and be shipping for our online shop, we can easily add them. Now, you have to bear in mind that you might not be there when they finish negotiations with Max.ng. You might go and have your own company. So you have to build it in a way that the next person can easily work on it without breaking the code. Now, let's say that this is how we have built the code. We have the one for the Federal Express shipping. We have for the test UPS shipping, and then for the Nigerian Postal shipping. When we run this code, of course, everything has passed. We will pass the test when we run it. But let's look at the classes that we have. We have the order class. Now, I want you all to please take a look at that order class very well and look at the shipper class, the 2 classes that we have. These are the classes that also help with that main.py. This is another class, the shipping cost class. Also look at the shipping cost class. Very well. Now, in all these codes that I have shown you, these 3 or 4, there are some flaws in it. First, it violates the single responsibility principle, which I said 1 class for 1 responsibility. If the class is for your recipe, let it be for your recipe and not for your utensils. Now, if we look at this class order, you can see that we are working on order, and then down we came and started with shipper. This class should only be for orders. The next is it violates open-closed principle. We'll look at that. The next, it violates dependency inversion principles. And when we look at this, there is a long list of if, elif, else. Now, this is what a strategy pattern structure looks like, more or less. You have the context, and you have the abstract class, and then the concrete strategies. Now, how this supposedly should work is you have your context, you have your abstract classes, and then the next person that comes in can simply add another strategy. Meaning the process flow has not been broken. Now, this is what the shipping cost strategy structure should be like. We should have the shipping cost, and then it should have an abstract strategy. Now, the shipping cost should have for FedEx, for the Nigerian Postal Service, and for UPS. If we modify our code, this is what it will look like when we modify it, using the strategy pattern. Now, if we look at this, we can see the difference between this one and the last one. Now, the thing is, with this one, when the next person comes in, or when somebody else forks our code, the person knows the person is just to add another class for, let's say, max.ng. That is what the person should do first. The person should not go to FedEx strategy class and put max.ng, or go to the postal strategy and input that for max. Then in our main.py, this is how it works. Now, the difference is that with this, the person only has to make 2 changes, more or less. Add 1 more class for the max, and then come into the main here and instantiate where he wants to. That is the only difference if you follow the strategy pattern. With this code that I have shown you guys, what we have fixed, we fixed all the problems that it had. Now, they can test the algorithms in isolation. Like when there is an error, and you know that, oh, this error is from max.ng class and not from FedEx class that also has max in it. You can test outer code with deterministic algorithms, and there are no more long list of if, elif, or even else. That is how the strategy pattern helps make our code readable and writable. Now, there are plenty of variations for strategy patterns. I just used it in classes and all that. But strategies can be applied in functions, lambdas, and lots of other things. You just need to look for where it is being violated. And I think it's quite simple to see where the strategy pattern is not being used, because you know that this is for this, and this one is for this one. But when 2 things are being mixed in one, it has violated that. Now, the summary of the strategy pattern. It it has done well, it's encapsulated the algorithms, several techniques available, not just what I used. There is plenty other ways to solve the problem we had previously. And the sequence of if-elifs are a red flag. It's another way for you to know if that strategy pattern was being used. If there is a long list of if, elif, and else, please go back and see. Another pattern that we'll look at is the observer pattern. Again, it's a behavioral pattern. It helps with one-to-many relationship, and it's between a set of objects. When the state of one changes, its dependencies are being notified. This is how a behavioral pattern should work. If, what example do I use now? Okay, let's keep going. This pattern can also be known as a dependent pattern or publish-subscribe pattern. Now, the example I wanted to use. This pattern, like the publish-subscribe pattern that it's known for things like newspapers, right? Yes. Let's say Punch has a mobile app. This pattern can help fine-tune their process of notifying you when there is a new issue. Or let's say a blog. This can also help to notify you or fine-tune the process of notifying you when there is a new post. We'll be using an example for a dashboard of a tech support center. Now, our client has told us that this dashboard should be open for tickets. It should show new tickets in last hours. It should send the notifications out to us that for the last hour, look at the new tickets. And it should also show closed tickets in the last hour. Now, the dashboard is the observer in this case, and the KPI source, which is this list of 3 things that we have to do, are the publishers. I hope that's understandable. The dashboard, which is, let's say we open the page, and the page is a dashboard. Now, this dashboard is the observer. The publisher is the open ticket, the new ticket, and the closed ticket. Now, let's look at this. At this one right here. Please, you can see where we're collecting the collections, the data, how we're collecting it. This is another one. Now here you can see what we're doing. We're printing where there is open tickets, where there are new tickets, and where there are closed tickets, all for the last hour. We're simply printing it. We're not sending it out yet. Now, when we run this, we can see that everything is passed. It tells us how many tickets we have in the last hour, how many open tickets we have, and how many closed tickets we have in that hour. Now, this is how the observer pattern works. There's a subject. It should notify the observer, which I said is that dashboard, and then it should get this state and set it back to the subject. If we use this pattern, the only thing that has to be added in case of new things, let's say the client now comes in and says, oh, you know what, and I want to get a notification anytime one article is deleted or one ticket is deleted. I want to get a notification. I want to get a notification when the ticket has been responded to. If we follow this process, there will be a long list of things that we have to work on to get it working. Now, using the example I gave, this is what the observer pattern UML should look like. You have the abstract class, the abstract subject, pointing to the observer. And from there, the observer, the concrete observer, will get information from the concrete one and keep passing it to whatever changes you make. Now, this observer pattern, what does it help us do? Separate consent for us. Like, we know that those three things the client mentioned, for open tickets, closed tickets, and tickets in last hour, when a new consent comes out that he wants to see when the ticket is being responded to, that is a new concern. And with this pattern, we can separate that concern. Single responsibility principle. It still follows that single responsibility principle. So you do not have to make changes to the whole code if possible. Interface segregation principle, the open-close principle, dependency inversion principle, and encapsulate what varies. There are other patterns, but because of time, I'll just list some. We have the command pattern. The command pattern is also behavioral, and it encapsulates a result, a request as an object, parameterizes objects, queues and logs operations, undoable operations and macros. It's also known as the action pattern and the transaction pattern. Now, this command pattern is what we use or is what is put in place for us to use the command lines and GUIs, so that we can know when there is an error and when our code is going smoothly, or when our code is going smoothly with warning. Other patterns are singleton pattern, factory pattern, builder pattern, and there are lots of more patterns that can help make our code readable and reusable. Thank you.